Okay, so here we are, 7.2 on the sine ratio. Now, taking a look at this page, it starts off talking about similar triangles. And this is super important when it comes to trigonometry in terms of the angle and the relationship between the sides and the angle. So here they're showing you two similar triangles, triangle ABC. They're saying is similar to triangle XYZ. And what they're saying is that this angle is the same as this angle. Now we must understand that the ratio of sides would have to be preserved. So A and X are related, and Z and C are related, and B and Y are related. So in trigonometry, you only deal with two sides at a time. So let's take a look at the relationship with X and Z and C and A and how they are related. Okay, so we know that from a similar triangle that if you're going to do the ratio of A over X, so this side divided by this side, it would have to be in the same proportion as if you were to do this ratio C on top of Z. So that ratio has to be preserved. We can skip all this and we come down to this bottom thing here. And this is the first trig ratio, it's called. So it says when triangles are similar, the ratio of the length of the side opposite a given angle to the length of a side of the hypotenuse is always the same. Okay, so I'm going to say that one more time. The ratio of the length of the side opposite, so opposite, to the length of the hypotenuse is always the same. So what does it mean to always be the same? Well, we're going to come up with this mathematical relationship called the sine ratio. And the sine ratio is abbreviated SIN. Do not call it sin, it is sine. It relates the opposite side of an angle to the hypotenuse. And if the angle is the same, that ratio will always be the same. The sine ratio used to be calculated off a chart. People would, before the invention of calculators, people would have to use a chart. Nowadays with the calculator, you just simply type it in, press the sine button, and then the angle. Your calculator has to be in degree mode. There's usually a DRG button that you can press. Watch your screen until it says DAG or D. This is what you need to see on your calculator. You can confirm that by trying these. Type in sine 15, see if you get this decimal. Type in sine 30, see if you get this decimal. If you are, your calculator is in the correct mode and you're good to move on to the next part. So build your skills number one, calculate the value of sine A to 2 decimal places. Alright, so let me just jot down the formula for sine one more time. Sine x equals op divided by hyp. What a lot of people do on the left side is put a 1 here as a placeholder, and it will help you with stuff later on in the unit. So, oh, they want us to use A here, so let's just use A. Sine A, because that's what they want us to do. And A is the angle that they want us to work with in this question. So here's the angle A. It says calculate the value of sine A. So sine A is equal to the ratio of the opposite side to the hypotenuse. So to find the opposite side, you go straight across. This is your opposite side. And they say that you're supposed to take that number and divide it by your hypotenuse. And we know from the last section that the hypotenuse is straight across the 90. So we're trying to calculate sine A, which is 4.3 divided by 6.9. 4.3, I'm typing in my calculator now, 4.3 divided by 6.9 is 0.62. They wanted it to 2 decimal places. Alright, let's try B. We're using this angle in the corner because they're asking us to find the sine of angle A. So sine A is equal to, I'll put a 1 over here, opposite divided by hypotenuse. Okay, so which side is opposite A? Straight across. Here is your opposite. Find the 90. Straight across. Here is your hypotenuse. So we're just going to ignore the 8.1 for now. So op is 5.2 dividing 9.6. So typing in my calculator, the ratio, 5.2 divided by 9.6, 0.54. So it's important that you understand that a ratio can be expressed as a decimal, and it's important to understand that this ratio is consistent for all similar triangles. And it's determined by this thing called sine. Opposite divided by hypotenuse. You could also do cosine and you could also do tangent. Those are the 3 that are on the calculator that you'll be able to notice. So on the calculator you probably see sine, cos, and tan. In this lesson, all we're worried about is sine. The next lesson will be cos, and the lesson after that will be tan. So right now, all we're worried about is the sine ratio. So what we just did above there with the ratios, you could also, like using the sides, you can also find those decimals by just calculating the sine of the angle. So sine 10, I'm literally just typing into my calculator, 0.1736. Sine 62, 0.8829. Sine 48, 0.7431. And sine 77, 0.9744 after rounding. So if you're not getting those, your calculator is probably in the wrong mode and you need to seek assistance. What this page demonstrates is that if you have the angle, you can use your calculator to find the ratio. And if you have a picture with the sides, if you have the sides, you can also calculate the ratio. And I'll show you a trick in a few seconds that will allow you to find the angle if you know the ratio. Alright, we can skip this one. And now we're looking at example 2, and it's a picture of a house with looks like a ladder leaning up next to the house. So this picture shows us that we can use trigonometry to help us solve problems. And that's basically what trigonometry is used for, is to solve everyday problems that involve right angles. So I'll just make that note here. If you take a look at the ladder leaning against the side of the house, the shape, the basic mathematical shape that it makes is a right triangle. And you can only do trigonometry with right triangles. Okay, so just make a note of that. Right triangles only. Okay, question 4. So now we're actually going to be trying to solve a problem. So number 4 says, calculate the length of the side opposite the indicated angle in the following diagrams. So all we need is some of the skills we used on the previous page. So we'll need to know sine 58, and we'll need to know where the op and the hype are. So this is what we need to find out for question A. So the formula that we're using says sine A equals, and I'll put a 1 here, op divided by hype. So sine 58 degrees over 1 equals op over hype. So when I'm looking at my picture, I'm using this angle here, 58 degrees. So I know the angle. If I go straight across, this is the opposite side that they're trying to that's what they're trying to do. Calculate the length of the side opposite the indicated angle. And then if I go straight across the 90, this is the hypotenuse. And I can fill in the spots on my formula. This opposite is the unknown, and this hypotenuse is the known, so I can put it there. Alright, now I'm ready to solve. This is just cross multiplication like you've seen this whole course. So I'll evaluate sine 58, and I'll go to 4 decimal places for accuracy. 0.8480 over 1 equals op over 9.7. And now I can cross multiply. So I just need to take 0.8480 times 9.7 divided by 1, and I got that this op, this side here, is 8.2. Okay, let's try the next one. Going to use this angle here, 23 degrees, so I know that it's going to be sine 23 degrees over 1 equal to op over hype. So I'm still using this formula over here. So the opposite is on top, and if I go straight across, they're referring to this side here. So op is unknown, and if I go straight across the 90, this is the hype. So that's 9.7. So it's it's got the same measurement, 9.7. However, the angle's different. So we should expect a smaller result because the angle's smaller. And the opposite side is either going to be large or small depending on the size of the angle. So sine 23, if I type that in my calculator, I get 0.3907. I go to 4 decimal places for accuracy. Now I cross multiply with that ratio. So 9.7 times 0.3907, and I got 3.8. So this is 3.8. Whoops. 3.8. Okay, a rafter, I don't know what that is, makes an angle of 28 degrees with the horizontal. Okay, so I know what a horizontal is, so I can put that in. It's a horizontal line. It says the rafter is 15 feet long. It says what is the height at the rafter's peak? Okay, I don't know what the heck they're talking about, but I know what a height is, and I know I need a right angle. So all I'm going to do is draw a vertical here, a vertical height. So I guess I need a right angle triangle. That's what I know. So I'll just draw that in. So it says the rafter makes an angle of 28 degrees. So the 28 degrees must be here. It says if the rafter, this must be the rafter, whatever that is, the rafter is 15 feet long. Then it says what is the height? So that's the opposite side here, the height. And the rafter is the hypotenuse, the rafter. So I use my formula that says sine, the angle goes next to sine, over 1, equal to the op, I can call h if I like, that's the height, divided by the rafter, which is 15 feet. Okay, so sine 28, figure that out. Sine 28 is 0.4695 over 1 is equal to h over 15 feet. So cross multiply. So 15 times this 0.4695 divided by 1. H is 7 feet. Okay, how high is a weather balloon tied to the ground if it is attached to a 15-meter string and the angle between the string and the ground is 35 degrees? Okay, so you need a right angle triangle. Typically I always just draw one of those and then I fill in the numbers after. So it says how high is a weather balloon? So that's this. How high is the weather balloon? And it's tied to the ground to a 15-meter string. So like this is the string of the balloon. And here's the balloon. Funny looking balloon. So that's 15 meters. And it says the angle is 35 degrees between the ground and the string. So same formula. Sine 35 over 1 equals h over 15. It's always the opposite side. I'll fill that in for you right now. The opposite side to the angle is h. So that's why I put it up top. And the adjacent, or pardon me, the hypotenuse side is across the right angle. So that's why I put the hypotenuse down here. And it's always op over hyp for the sine equation. There's 2 more equations to go, and right now we're only worrying about sine. So let me figure out sine 35 in my calculator. 0.5736 after rounding 1 equals h over 15. So cross multiply times by 15, divide by 1. H is 8.6 meters. Okay, so in all these examples, number 6 and number 5 and number 4, we were always solving for the op. So I'm pretty sure that in these next examples, we'll probably start solving for the hypotenuse. Yeah, that's what they're doing here. Okay, so let's just run through these quickly because it's almost identical. So sine 33 over 1 equals 7.8 over h. Here's the op. Here's the hyp. Now when we, okay, let me just figure out sine 33. 0.5446 over 1 equals 7.8 over h. So now when you cross multiply, just be careful that you're doing it properly. You always times the 2 numbers that cross and divide across the unknown. So for this one, you would go 7.8 times 1, which does nothing, divided by this new ratio of yours, 0.54. So 7.8 basically divided by 0.5446. And H is 14.3. So that's what we should expect to happen. Our number got bigger. You can see 14.3 is greater than 7.8 because the 14.3 is the hypotenuse, and that has to be longer. The hypotenuse is the longest side, so your number should get bigger, and that's a good way for you to check if you've done things correctly. Alright, moving on to the next one. Across the angle is the opposite side. Across the 90 is the hypotenuse side. The formula relates sine of the angle over 1 is equivalent to the opposite side, 12.1, divided by the hypotenuse h. And cross multiply. So it's going to be 12.1 divided by sine 70. And, you know, in the previous examples, I was figuring out the sine value first. And you don't have to do that step. I was just doing that to help. You can do it right off the bat, you know, depending on how your calculator behaves. So if you're having questions about how your calculator works, please let me know and I can just steer you in the right direction. So H here is equal to 12.9 after rounding. Okay, number 8, how long is a wire that is attached 4.2 meters up a pole? This diagram doesn't look like it's from your book. I think this is copied in. So you would have to draw it yourself. It says 4.2 meters up a pole. So this must be the pole. Poles go straight up and down. And it says how long is the wire? This must be the wire. And the wire is attached to the pole and makes an angle of 52 degrees with the ground. So there's the angle. It says how long is the wire? So you're trying to solve for the length of the hypotenuse. So sine 52 over 1 equals 4.2 over the hypotenuse, which is the length of the wire. Cross multiplying, you'll see that you'll have 4.2 divided by the sine of 52, which is 5.3 after rounding. Alright, number 9, it says a boat is carried with a current at an angle of 43 degrees to the shore. If the river is approximately 15 meters wide, how far does the boat travel before reaching the opposite shore? Alright, so I'm just going to draw in a river. The river is 15 meters wide, so you can draw in the distance like this. We know that to be 15. And it says a boat is carried at an angle of 43 degrees to the shore. So the boat must waver off its intended direction. And you get a right angle triangle. Whoops. So you get a right angle triangle like that. This must be the 43 degrees. And they're asking for the hypotenuse, because the boat would travel like da 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 da. That's the boat traveling, because the current is probably pushing it across. The boat thinks it's traveling up and down, but the current pushes it to the right. So we say sine 43 over 1 equals no, this is incorrect. The angle's in the wrong spot. 43 is here. So the current must be pushing it to the left. So the boat is traveling actually down and left. Not a big deal. You won't get questions with boats and currents. This is a little bit too challenging to set up for this course. So it's 15 is the opposite divided by the hypotenuse, and it's the same style. Straight across, op, find the 90, straight across, that's your hype. So 15 times 1 divided by sine 43, and it's 22 after rounding. Okay, this next picture is very important. It's called angle of elevation and angle of depression. So you have to imagine you're standing on a cliff, and this is you, and you have these things called eyeballs, and you look with your eyeballs. Now, how to say what angle I'm looking at? We need the horizontal. The horizontal is like a measuring reference point. So from the horizontal, you could have an angle of elevation, which goes up. And if you think about the word elevate, you're thinking up, you're feeling positive. Elevate, elevation, you're feeling up. So the elevation goes up from the horizontal. Now, if you look down from the horizontal, like this, they would call that the angle of depression. And I'll use red for that because you're feeling down, you're looking down, angle of depression. So that's an easy way to remember. But the most important thing is that you're going from a horizontal reference point, because how else do you know where to start? So the horizontal is your reference. If you go up, it's an elevation. If you go down, it's a depression. So it looks like 3 more and then we are done. So it says George is in a hot air balloon that is 125 meters high. So you would draw your balloon. This is you in the balloon. Yay, I'm in a balloon. Whatever that thing looks like. And it says that the angle of elevation from a house below. So here's a house. And you look from the house to the person in the balloon. You make a right angle triangle. And it says angle of elevation. Oops, I shouldn't use red. I should use blue because we're feeling happy. Angle of elevation. You're feeling elevated, so that means it goes up. And it says that it's 18 degrees. And then we know that it's 125 meters high. And then it says, how far is George from the house? So they want to know the distance of the hypotenuse. So we say sine 18 over 1 is equal to the opposite side. So 125 is the opposite side divided by the hypotenuse. We can cross multiply 125 times 1, dividing sine 18, 404.5. And the unit is meter. Okay, we have a road. So there's a subtle incline in the road. It's 4.5 degrees. It says, what is the length of the section of the road? So if you were a car, boom, boom, like this. Oh yeah, good picture. The hypotenuse, because this is the right angle here, this is the road. This is the road. And it says it rises 16 meters, so this is 16 here. So they want you to find the hypotenuse. So here I have the equation built because 16 is the opposite side to the degree, and we're trying to solve the hypotenuse. So op divided by hype on one side and sine of the angle on the other. Cross multiply 16 times 1 does nothing, so it's just 16, and then you divide out the thing across the unknown, which is sine of 4.5. And I got a value of, after rounding, 204 meters. Now I hope that makes sense. If you think about 4.5 degrees, it's a very tiny angle. So you have to travel 204 meters on this road before you have eventually risen 16 meters. Because it's such a small angle. When you're driving, you probably wouldn't even notice that that's happening. Okay, I like how this book didn't even offer an angle of depression question, so that's awesome. So let's do that. Let's change this. Let's say the angle of depression. I'm changing this question. And it's in red because I'm sad. I'm down. The angle of depression of a slide that is 3.6 meters long is 32 degrees. How high above the ground is the top of the slide? Okay, so let's draw that in. So we have to draw in a slide. So everybody knows what a slide looks like. So this is the slide. Now, the important thing is the angle of depression. To do that, you need an imaginary horizontal reference point, like that. Then I take out my red pen because I'm depressed. And it says the angle of depression is 32 degrees. So that's right there. And then I remember back to my studies of chapter 5. I know what a complement is. 90 take away 32. 90 take away 32. So right here that's 58 degrees. So I can put 58 degrees inside my triangle. A lot of kids think that the angle of depression's in here. That is a mistake. The angle of depression goes from the horizontal down. And in fact, an interesting tidbit is that the angle of elevation equals the angle of depression. And that's also from chapter 5, if you recall, parallel lines and a transversal. So parallel line, and a transversal. So I know that angle 32 is also right here. The other thing I could have done is 180 take away 58 take away 90. That's also going to be 32 for this angle down here in the corner, because I remember all my chapter 5 angle stuff. Okay, so let me just redraw this picture because it's become pretty messy. I know that's 32 down in the corner. So that's a good thing to remember. If they ever give you angle of depression, just use the angle of elevation because it's the same. Okay, so let's put in the side lengths. It says that the slide is 3.6 meters long. That's the hypotenuse. Then it says how high above, so that's the height, h, which is the opposite side to the angle 32. Alright, so sine 32 over 1 is equal to h, the opposite side, on top of 3.6, the hypotenuse. Cross multiplying now, it would be sine 32 times 3.6 divided by 1, which doesn't change anything, so it's 1.9 after rounding. Alright, that looks like that's it for Build Your Skills. Definitely practice all these questions because there's only 5 of them. Okay, you will not get good at trigonometry unless you practice it and get used to the patterns. Good luck.